Dear students, in today's lecture, we will discuss the sterically hindered reaction. Sterically hindered reaction means the steric requirements of a compound in a transition state is more than a ground state. The steric requirements means there is a crowding. Okay, the words I said, the steric requirements in a transition state means the steric crowding in a transition state if more than the ground state, then the more crowded substituent react slowly than the less crowded substituent. And also the way of your group is attached to your cyclohexyl ring also decide the rate of reaction of that particular conformation or particular group. We have question, we have these two types of the reactants is there, and you found that trans isomers react rate of reaction of trans isomer is higher than the rate of reaction of the cis isomer. In all this, okay, in this case it is 20 times faster. K trans is 20 times faster than the cis. And in first case, the trans isomers and there is no much difference we found in first case, but somehow the trans isomers react faster than the cis isomer. But the difference when you compare with the 4 tertiary butyl cyclohexane carboxylate, you found in this case the rate of trans isomer is much higher than this molecule, that is 4 tertiary butyl cyclohexyl paranitrobenzoate. Okay. Now for the steric hindered reaction, we will simultaneously discuss these two reactions on the basis of also why the rate is in this case is the 20 times, and in this case is the 2.25, and also the why our crowded molecule react slowly, we will discuss in this lecture. There are the two types of reaction, sterically hindered reaction and the sterically assisted reaction. In a sterically hindered reaction, less crowded reactant react fastly, and in a sterically assisted reaction, the more crowded reactant react fastly. This is difference between the steric hindered reaction and the steric assisted reaction. Remember that in steric hindered reaction there is we said that steric requirements. Okay, steric requirement is there is a crowding, steric crowding. Remember that steric requirement is here, steric crowding. If steric requirements in a TS, that is transition state, is greater than ground state, then this reaction is a sterically hindered reaction. There is some hindrance is there, some opposition is there, that is the sterically hindered reaction. And if the steric requirement That is steric crowding. Okay, when steric requirement you consider, that is a steric crowding. If steric requirement in a TS is less than ground state, this is your sterically assisted reaction. Now we will start with our first molecule. Simultaneously we will discuss again the second molecule. We have its cis form is like that: tertiary butyl, our para nitro benzoate. This is our first compound, and second compound for this tertiary butyl cyclohexane carboxylate. These two compounds. Okay. When we saponification of our the first compound, saponification of first and saponification of second compound. Okay, saponification is you add the OH minus in this compound in presence of the base. Okay, when you add the OH minus to this is our cis compound. Okay, remember that cis, tertiary butyl cyclohexyl para nitrobenzoate. This is our second compound, cis tertiary butyl cyclohexane carboxylate. Okay, in this case we have said that the rate of reaction for the trans is the higher than the cis. Okay, 20 times higher. Rate of reaction of saponification of this carboxylate ester is 20 times is more for the trans, and for this our trans isomer and the cis isomer it is 2.22. Okay, as compared to this molecule, this is shows the reaction rate of trans isomer is the higher. Okay, the transition state for this is you obtain is like that. Okay, for this you obtain the transition state. This there is a change is there. Okay, in this case change is there. Okay, in transition state your carbonyl group, okay, that is sp2 carbonyl group is converted into sp3 carbon, and sp3 carbon is the more crowded than your our carbonyl group. In this case also our sp2 carbonyl group is converted into sp3 carbon. Okay, in first case this sp3 carbon is apart from cyclohexyl ring by oxygen atom. Okay, you found that this tetrahedron carbon, sp3 carbon also called as the tetrahedron carbon, is away from this cyclohexyl. Okay, this ring is your cyclohexyl ring. Okay, therefore this tetrahedral carbon is away from this cyclohexyl ring. In case of this molecule, cis tertiary butyl, okay, both cases, cis or trans, your tetrahedral carbon is near to the cyclohexyl ring. Remember, near to cyclohexyl ring. Okay, when you have the trans isomer for this, you will obtain the trans, give the trans product. Remember that. Okay, this in this case also there is a transition state is there also. Okay, in this case if you have the trans isomer, you obtain the your transition state like that. Again, in both cases, if it is a trans, it is very near to this cyclohexyl ring. But this molecule or this component, when you compare its reaction rate of these two molecules, this molecule and this is your cis and this is trans. Okay, this is and this is trans. Trans molecules react 2.25 times faster than this molecule. But when you compare these two, you found that your cis molecule reacts 20 times faster than the trans molecule. Why such difference is there? It is having only 2.25 and it is having the 20, it is more than this. Okay, when you compare this to this, you found that this has the more cis compound is the trans compound has the more reaction rate than the our cis compound. But when compared to these two reactions, saponification of these two, you found that in first case it is a trans react 2.25 times is more than the cis. In this case, trans react the 25 times faster than this. Such in this case, you found that it's very late. Its rate is the not more than this. This we have explained on the basis of this carbon after saponification often the TS. In TS, our carbonyl group is converted to tetrahedral group, and this tetrahedral carbon is away from the cyclohexyl ring. Therefore, in such cases, the crowding is not much more than when these tetrahedral groups is near to your cyclohexyl ring. If cyclohexyl ring near to this, okay, is close vicinity, your sp3 or tetrahedral carbon is the close vicinity to this cyclohexyl ring than this. Therefore, this group is your tetrahedral group is the away from this ring, and this group tetrahedral carbon is the near to the cyclohexyl ring. Okay, as compared to the first compound cis or trans, or as compared to this compound cis or trans, you found that in this compound the tetrahedral carbon plays important role for the difference between reaction rate cis and trans. This is the crowding situation than these two situations. Therefore, when the crowding is released in the equatorial group, therefore it reacts 20 times cis, trans isomer react 20 times faster the cis isomer. But when you compare these two reactions or these two conformation, it is found that in first case trans isomer react 2.25 times more than this, and it is very less than 20 times. See, 20 times because your tetrahedral groups is near to this and it creates the highly crowding situation. Therefore, at axial position, if highly crowding situation is there, this molecule reacts very, very slowly. And in axial molecule, sp3 is near to this, but this reacts very far than this, because this is very, very slow. It reacts very, very slow because the sp3 is the very near to cycloaxial. It creates the 1,3 series 1,3 diaxial interaction, and in this case your sp3 is the away from sp3 carbon or tetrahedral carbon is away from our cycloaxial ring. Therefore the crowding is in this case also there is crowding, but the crowding is shifted from the away from the cycloaxial ring. Therefore, in this case, we found that no much difference of reaction of trans isomer and cis isomer, but some difference is there. Definitely, the crowding compounds gives the slow reaction than the less crowding compounds. Okay. Therefore, in this case, you found that in TS there is a steric requirement is higher in TS than the steric requirement in the ground state. Therefore, in a sterically hindered reaction, the crowded molecule is reacted in slow, it is reacting slowly in crowded molecule. This is about the, we have discussed the why the saponification K trans upon K cis for the particular molecule is higher than this molecule. And again simultaneously we discuss there is this reaction is the sterically hindered reaction. This is all about the sterically hindered reactions and the why the K trans upon K cis is higher for this molecule than this molecule we have discussed in this reaction. Thank you very much.